Dear students, today I am going to discuss Digital Signal Processing Laboratory, experiment number 3, linear convolution of given sequence. So I am going to discuss the aim of your experiment. Linear convolution of the given sequence. Aim: to perform the linear convolution of two finite discrete sequence using simulation software MATLAB. Now I will show the simulation of this experiment using MATLAB. Now I will conduct the experiment, that is I will do the practical demonstration video of this experiment.
Now this is the program I am going to run through MATLAB. So the first three commands I already said. CLC means clear the command window, and clear all means whatever the data which is stored in the workspace that will be clear, and close all means whatever the window which is opened previous program that will be closed. Now I am going to give the input sequence, first input sequence as x1. It can be any length, and the second input I am going to give, and that also it can be any length. That will be naming as n1. N1 is nothing but length of x1, and n2 is nothing but your length of x2. Now you know that linear convolution means that is non-periodic convolution. The capital N means number of samples, that will be equal to n1 plus n2 minus 1. So now x1 is nothing but x1 zeros 1 comma n minus n1, the capital N minus n1, 1 comma that many. So suppose if the length of the sequence is less means that for that we are going to use that x1 and x2. M is nothing but your time, that will be m is equal to 0 is to 1 is to n minus 1. Now I am going to use the for loop. When n equal to 0 is to n minus 1 means up to that the data will be taken and it will be stored, and then it will be y of n will be getting increment, and then up to the last value it will be taken and the process will be continue. So the dot symbol represents the linear convolution. The dot star is nothing but your linear convolution between x1 and x2. So that is x1 and x2 we will perform linear convolution, and then we have to add the output. And the next one is display linear convolution, that is the convoluted sequence will be displayed, and your first sequence will be displayed x1, and the second sequence will be displayed x2, and your third sequence is nothing but convolved sequence y. Now subplot, the entire screen will be splitted into 3. In that your first row, first plot will be plotted. For that stem is nothing but for the corresponding time and amplitude axis, it will you will give that discrete values. The next one, title, that is first sequence will be plotted. X label you are going to give signal, Y label you are going to give time. That is your wish, you can give whatever you want. So now next one is taken this stem x2. So title will be given second sequence, X label, Y label, and subplot will be given. Next title is final convolved output. For that also you are giving X label, Y label. Now I will show the simulation result. So first sequence I am going to give, your first sequence will be so see, if I give this this bracket, that is open bracket, see I am getting your error. Okay, so this so if you run the program, you should give this bracket. So as I said earlier, sorry, here so now I am going to run the program.
When you click this run button, then you have to go to the command window. So it will ask for the enter the first sequence. In that you need to enter the matrix 1, 2, 3, 4. So again it will ask for the second sequence. If you enter 1, 2, 3, 4, then you give the enter, then the sequence will be generated, that the linear sequence will be generated and its corresponding graph. So we have seen that it has been step signal. so it will be discrete. So at every point of time the signal will be discrete. It is your first sequence and this is your second sequence. At every point of time, that is from time 1 to 7, the signals are discrete and it is shown over here. So it is the output. Again, when you see the output, you could see the sequences that has been generated. It is your first sequence, that is x1, 1, 2, 3, 4 and 0, 0, 0. It is not mandatory that your first sequence and second sequence has to be in the same order. Anything you can give it. Again, when you run the program for different sequences, different convolute sequence will be generated and its respective graphs have been plotted.
This is the data which we have entered in the command window. Enter the first sequence 1, 2, 3, 4. Enter the second sequence 1, 2, 3, 4. These two lines which we have used in the program, and the first sequence will be 1, 2, 3, 4, 5, 0, 0, 0. Why this 0, 0 appended means we know that linear convolution. Actually, the formula for the linear convolution n will be is equal to n1 plus n2 minus 1. So if you add this two sequence, length is 4, this length is 4, 4 plus 4, 8, minus 1, it is 7. So the sequence of this first sequence length and the second sequence length should have 7 samples, so that I have appended 3 zeros at the end of each sequence. After convolving this, you will get the convolved sequence 1, 4, 10, 20, 25, 24, 16. The next, this is the output which we have got when we simulated the experiment, and this is the result. Thus the linear convolution of two finite discrete sequences simulated in MATLAB, and output is verified. Thank you, students.